Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize some of the top stories in science, including the Polar Vortex. Why is it that the Northeast is gripped by this gigantic freezing spell, which is causing casualties, accidents, destroying crops, property? What's behind this polar vortex that seems to be gripping a huge chunk of the U.S. of A? And also news from outer space. Is there a gigantic megastructure built by aliens, an alien civilization creating an object that surrounds Tabby's star? Well, astronomers have focused in on Tabby's star, this strange anomaly that seems to be blinking at us from outer space. And, well, their latest conclusion is perhaps it's not an alien structure, but then what is it? And then Stephen Hawking has a new TV series where he takes a trip to the planet Venus. Why Venus? And it has to do with something called the greenhouse effect. Venus is the greenhouse planet. So we'll say a few things about space, about the greenhouse effect, and what's happening here on the planet Earth. And also, I'd like to make a short announcement, and that is I'm going to be on a book tour in the end of February. In fact, I'll be passing through the Bay Area, Los Angeles, Chicago, Washington, D.C., Boston, New York, and Berkeley. In fact, I'll be speaking on behalf of KPFA Radio, our Pacifica affiliate, and I'll be speaking about my latest book called The Future of Humanity. We're going to take the big look at the question of the space program. Is it a waste of money? Are we getting our return for all our taxpayers' funds? And some people think that that's the future, that one day we will begin the colonization of Mars and beyond. Well, let's not get ahead of ourselves, but let's talk about why the Northeast is gripped by this gigantic freeze that's unprecedented in recent modern history. Why is it that we are setting records throughout the country? In New York City just a few days ago, the temperature reached 5 degrees above 0 Fahrenheit. And in other cities around the country, it went way below 0. And the question is, why are we having such unusual weather? Well, President Donald Trump came in and said, well, maybe we could use a little bit of good old global warming. Well, is there a link between global warming and this freeze that is gripping the United States? It seems to defy common sense. But we have to go back to what is called the polar vortex and why it's being destabilized. First of all, if you take a satellite photograph of the North Pole, you realize that there is a cap of swirling cold air, a vortex of cold air called the polar vortex. Usually it's quite stable. And the stability of the polar vortex is related to the jet stream. And so when the polar vortex is strong, with a very strong wall around it, the jet stream is more or less stable and doesn't wander so much. However, recent computer simulations have shown that the stability of the polar vortex can, in fact, be violated by global warming. And here's how it works. The stability of the polar vortex depends on the temperature difference between the center and the outside rim of the polar vortex. So think of a spinning bucket of cold water at the top of the North Pole. For the most part, the bucket seems to be stable. However, the stability of this bucket depends on a large temperature difference between the inside of the bucket and the outside of the bucket. The bigger the temperature difference, the faster the winds move, and the more stable it is as a consequence. However, and this is the killer, it turns out that the temperature of the North Pole and the South Pole is rising twice as fast as the average temperature around the planet Earth. For example, if you go to the North Pole 50 years ago with the Nautilus submarine, you can measure the thickness of the ice. 50 years later, when you go back to the North Pole, you find out that the average thickness is 50% thinner. In fact, over 50 years, it became 50% thinner, meaning that on average every year, the ice sheet over the North Pole gets 1% less. That is unprecedented in modern history. And it goes back to the fact that the average temperature of the North Pole and the South Pole is rising twice as fast as the average temperature around the rest of the planet Earth. Now, why is that important? Because as the temperature inside the vortex becomes closer to the temperature outside the vortex, the wall becomes unstable. Temperatures begin to rise inside, walls begin to become wobbly and less stable, and the jet stream starts to meander as a consequence. Now, you may say to yourself, is this science fiction? No. Satellite photographs of the North Pole that you can see on the web shows that traditionally there is a cap, a circular cap on the North Pole given to us by the polar vortex, but recently, especially over the last week or so, it's been wandering, pushing the jet stream further south. And that, we think, is one of the reasons why the polar vortex is unstable and why we're in this cold snap. So, ironically enough, it could have something to do with global warming. Now, you may say to yourself, what's the proof? Where's the smoking gun? First of all, this is a theory. It hasn't yet been verified by a universal consensus among climatologists. However, there is an emerging feeling, given a few computer programs that have been done, that this could be the reason why we have instability in the polar vortex. But I repeat, to be fair, this is not the universal consensus of the scientific community, because there are other factors involved which are also linked to global warming. As the ice sheets begin to shrink, it means that the amount of heat being radiated and reflected back into outer space begins to change. So the very fact that you have a gradual melting of the North Polar regions directly affects the amount of sunlight that's reflected back into outer space. The less ice you have, the less reflection you have. The less reflection you have, the hotter the Earth gets, because it retains the heat that normally would have gone into outer space. So that is yet another effect stimulated by global warming. But once again, is this the smoking gun? And the answer is no. We cannot say for sure that this is directly caused by global warming. Why is that? Because global warming is an average effect. It's an effect seen over years. And global warming does predict that when you complete the dots, you're going to see an average effect as temperatures begin to rise, as the atmosphere is destabilized as a consequence. But will you have some data points that are not on this nice line? And the answer is yes, because the weather is statistical. So don't believe it when anyone says for sure, with 100% certainty, that it is or is not caused by global warming. Scientists say that 95% confidence, that with 90 to 95% confidence, these effects are caused by global warming. And remember that global warming is a misnomer. We're not talking about a uniform warming of the planet at all. We're talking about global swings, because as the Earth heats up, the energy inside the Earth is trapped and sloshes around, creating forest fires and droughts in one area, creating cold snaps in another area, creating flooding in another area, all at the same time. And so global warming, unfortunately, is a misnomer. Also in the news, is there an alien structure in outer space that is the talk of the town within astronomical communities? Are the aliens in some sense trying to communicate with us? Well, it turns out that aliens are in the news. Just over a month ago, it was released that the United States Pentagon has in fact taken a look at these numerous UFO sightings. The study lasted until the year 2012. And $22 million were spent on this project by the military to analyze what's happening in the skies above us. Well, it's been over a month since that report was released. Since then, we physicists and scientists have been able to pick apart many of these sightings, and this is more or less the consensus that we come up with. First of all, there's really nothing new. Nothing new in these reports. There's no smoking gun. There's no one report where you can say, oh my God, this is it. This clinches it. Yes, the aliens are here in our backyard. There's no one incident that allows us to believe that. In fact, about 95% of what's inside the report can be explained by natural phenomenon. That is, atmospheric anomalies, storms, weather balloons, meteor impacts, even the planet Venus. Children often say that the moon seems to be following them when they look back and see the moon over their shoulder. Well, the same thing with the planet Venus. And if you're driving a car and you look back and you see Venus behind you, no matter how you turn left or right, Venus always seems to follow you. And that's one of the reasons why President Jimmy Carter lodged a request for the United States Air Force to investigate his UFO encounter. Well, scientists have had a chance to look at these reports. So the question is, what about the last 5%? 95% can be dismissed as radar echoes, as temperature inversions, meteors, weather balloons, what have you, natural phenomena, even some man-made phenomena. But the question is, what about the remaining 5%? A few of these incidences will make your hair stand on end. A few of these incidences record objects seen by multiple witnesses by multiple means, not just eyesight, but radar. Not just one person, but several people simultaneously. For example, years ago, there was the famous JAL sighting by the Japan Airlines, a commercial airliner where the pilot saw an object following it, going neck and neck with the airplane, in fact, doing all sorts of maneuvers, and it was tracked by radar and by visual sighting as well. There are a lot of these things. And then when you ask a physicist, well, is this within the laws of physics? Well, we have to hem and haw a bit because at the present time, we do not have any valid aircraft that can execute these maneuvers. However, since then, we now know that Area 51 is, in fact, a legitimate Air Force secret base where they test things like flying wings. They test things like stealth bombers and all sorts of harebrained schemes that may one day yield fruit and give us a super weapon on the battlefield. And some people believe that maybe it's a drone craft that has hypersonic velocity capabilities that can easily outstrip an ordinary jet plane. It is part rocket, part airplane. It is hypersonic, meaning that it can go much faster than the supersonic jets that we have today. And it is a drone, so that it can execute all sorts of maneuvers without crushing the pilots inside, because there are no pilots inside. Well, is that the solution? Well, as I said before, there's no smoking gun one way or the other. You see, science is based on things that are testable, reproducible, falsifiable. When someone says, yes, it's a UFO out there from outer space, how do you disprove that statement? How do you test that statement? How do you reproduce that statement? And that's where science comes to an end. And we need basically more data, a different kind of data. So I tell people that if they've ever been abducted by a flying saucer, then for God's sake, steal something. I don't care whether it's an alien paperclip. I don't care whether it's an alien pen, an alien badge, whatever. Steal something so that you have bragging rights afterwards, and you can go to the press and say, here is the smoking gun. Look at this chip, far beyond anything that we can assemble here on the planet Earth. That would end the debate right then and there. Or, if aliens have been doing forbidden experiments on your organs, well, alien DNA would clinch it right there. If, in fact, experiments have been done on your body, perhaps alien DNA have been left over by alien surgeons. And that would clinch it right there. No more speculation. No more hemming and hawing. We would have the smoking gun. But unfortunately, so far, no one has yet come up with an alien paperclip. However, that said, astronomers, legitimate astronomers, tune their telescopes to the heavens to look at Tabby's star to see whether or not it is a signal from an advanced civilization in outer space. Let me explain. We now know that many stars have planets going around them in outer space, and when a Jupiter-sized planet goes in front of a star, it dims the starlight by about 1%. And so by analyzing a periodic dip of 1% among the stars in the heavens, bingo, we know that there's a planet going around it. Well, Tabby's star was noticed by an astronomer nicknamed Tabby, and she noticed that the sunlight dipped not by 1%, but 20%. And it did it not just once, but twice. Once at 15% and once at 20%. Now, that left astronomers flabbergasted. Their jaws hit the floor. Nothing known to science can cause starlight to dip 15% and 20%, and to do it more than once. All sorts of cockamamie ideas were put forth by astronomers, and one by one, they were ruled out. One possibility was a comet storm. Another possibility was a dust cloud. Well, there are many problems with all of those. First of all, dust is found in young solar systems where planets have not yet condensed out of the dust swirling around a young star. So that's possible. Maybe the dust cloud obscured the light from the mother star periodically because it tilts with time. The problem there is this solar system seems to be mature. It doesn't seem to have a dust cloud around it. So, what did astronomers do? This time, they waited for the next eclipse of the mother star. It happened right on schedule. Every 2 years or so, we have this dimming of starlight that goes back, by the way, decades. When you look at star charts going back years, you can also see this same effect roughly every 2 years. So astronomers were waiting this time. They had their telescopes tuned. Sure enough, it began to dim. Not by 20% or 15%, but by a few percent. And it dipped several times after that, just in late 2017. Well, now in 2018, they're beginning to release the data. And they think, aha, we have a partial solution to this cosmic mystery. First of all, if it was an object like an artificial satellite, an artificial Dyson sphere, a gigantic object that absorbs starlight from the mother sun, then there would be a uniform shadow. A shadow that is cast in front of the mother star uniformly because it's a solid object. However, if it's a gas cloud, then the shadow would be non-uniform. At different frequencies, you would have a different absorption of starlight. So what they did was, this time they analyzed the dimming of the starlight, and they analyzed the frequency. Is it a uniform drop in starlight across all frequencies of the rainbow? Or is it just irregular? Well, the data just came in a few days ago, and the answer is the shadow is irregular. So some people are saying, aha, it means it's dust and not an alien civilization capable of creating a massive megastructure that can dim starlight by 20%. Other people are saying, not so fast, not so fast. That was a dimming of a small blip in the last few months. The big dips, we have yet to analyze what happens to the shadow when we have a big dip, not just these little dips that also take place. That remains to be seen still. And also, speaking about outer space, Stephen Hawking, my colleague, has a new TV program where he goes to Venus. Now, you may say to yourself, why Venus? After all, Mars is getting all the attention. NASA has already laid out a program to go to Mars. Well, you see, Venus has its attractions because it's also linked to, you got it, global warming. You see, years ago, before we knew anything about the planet Venus, science fiction writers said that it should be a tropical paradise. After all, it's a twin of the Earth. Mars is much smaller than the Earth, but Venus is practically a twin, just a shade tinier than the planet Earth, and is closer to the sun than the Earth, meaning that maybe it's tropical. So, science fiction writers envisioned Venus as a tropical resort, as a place station for astronauts. And I remember as a kid reading many science fiction novels where, sure enough, the astronauts would stop at Venus to refuel for a little bit of rest and relaxation before they blasted off to fight the aliens in outer space. Well, boy, were we wrong. Carl Sagan did a hypothesis. He said that let's assume that the atmosphere of Venus is carbon dioxide and it absorbs starlight. Starlight goes through carbon dioxide because carbon dioxide is invisible. You exhale carbon dioxide, you can't see it, it's invisible. But once it hits rock and the surface of the Earth or Venus, it warms up the Earth surface or the surface of Venus, and it radiates back heat radiation or infrared. Infrared cannot go through carbon dioxide very well. So starlight is trapped. Starlight easily goes through the atmosphere, hits the surface of Venus, is reflected back as infrared radiation, which cannot be easily transmitted through carbon dioxide, and bingo, you have a trapping of heat. That's the greenhouse effect. So Carl Sagan predicted that maybe there's a runaway greenhouse effect taking place. Well, sure enough, when our space probes flew by Venus a short time later, Carl Sagan was right on the button. The temperature of Venus is 900 degrees Fahrenheit. Hotter than a baker's oven. Hotter than the melting point of most metals, in fact. Tin is in liquid form at that temperature. If you were to walk on the surface of Venus, you could sink into a pool of molten metals. Very unpleasant sensation. And the atmosphere is also 100 times thicker than the atmosphere on the planet Earth, and it is almost all carbon dioxide. So if you were to walk on the surface of Venus, it would not be pleasant at all. First of all, if it rains, you expect the rain to cool down the surface, but no. When it rains sulfuric acid. You see, sulfur comes out of volcanoes, and Venus had volcanoes, and some of that sulfur turned into sulfuric acid. In fact, that's the irony. Venus is the goddess of love because it is so bright. The brightest object in the night sky other than the moon. But why is it so bright? Because its atmosphere contains droplets of sulfuric acid, which reflects sunlight to the Earth. And so the very fact that Venus is a hellhole is also the fact that Venus is the most beautiful planet in the solar system. It's because of the reflection of starlight by droplets of sulfuric acid. So walking on the surface of Venus is not pleasant at all. First, you would be crushed like an eggshell because the atmospheric pressure is 100 times that of the planet Earth. For example, on every square inch of your skin, every square inch, you have 15 pounds of pressure, air pressure, pushing down on you. Now, you may say to yourself, well, that's stupid. I mean, I don't feel it. If there's 15 pounds pushing down in every square inch of my skin, how come I'm not crushed? Well, it's because you have 15 pounds on the inside of your skin pushing out, and the two balance each other. Now you may say to yourself, well, that's really stupid. You're telling me that I have 15 pounds per square inch on the outside of my skin and 15 pounds per square inch on the inside of my skin? How do you prove that? Well, the proof is very simple. In fact, we do it at City College in physics experiments all the time. We get a chamber with a balloon in it. We inflate the balloon, and then we remove the air in the chamber. As the air in the chamber starts to be removed, that removes the 15 pounds per square inch on the outside of the skin of the balloon, leaving the 15 pounds per square inch on the inside of the balloon pushing out. What happens? The balloon begins to get bigger and bigger and bigger until it finally pops. And that's what will happen to you on the surface of Venus in the other direction. You will be crushed not by 15 pounds per square inch, but 15 times 100. That's the atmospheric pressure beating down on you. So walking on Venus, A, you would be crushed by the atmospheric pressure. B, you'd suffocate because it's all carbon dioxide. D, you would begin to sink into molten metals. And D, as you walk, it feels like you're walking through molasses because the atmosphere is so thick. In other words, it's the greenhouse effect. Venus is a hellhole because it is the greenhouse effect that has run away, and that could be the future of the planet Earth. That's what scientists fear, that maybe we're looking at the future. Maybe Venus has something to tell us about our future, because on Venus we had a runaway greenhouse effect, and look, it should be a tropical paradise. It is closer to the sun. It is a twin of the Earth. In fact, if you were to drag the Earth closer to the sun near the orbit of Venus, then we would start to resemble the planet Venus. So some people say it's basically a warning that we are looking at the future if we see the planet Venus. Well, I'm afraid that's it for the first part of exploration. Stay tuned now for the second part when we talk about, well, what are we going to do about it? Some people think that the answer is right in front of us, and that is solar power. But what about the economics of solar power? With us today in the second half of exploration is a businessman, Travis Bradford, author of a new book, The Solar Revolution. And he says it's only a matter of time. Only a matter of time before we have the inevitable victory of solar energy as we begin to conquer the problems of technical glitches, also mass production, and, of course, the economics of solar. And so once again, in the second half of exploration, our special guest is Travis Bradford, a businessman who is the author of a book, The Solar Revolution, who thinks you're going to make money on solar power. Welcome. This is Dr. Michio Kaku once again, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is the second half of Exploration. Now we're going to bring on somebody who wants to do something rather than simply complain about the weather. We have with us Travis Bradford, author of the book Solar Revolution. And we should mention that several factors are coming together to change the economics of solar. First of all, we have the plunging cost of solar cells and solar technology. Second of all, we have the rise and fall in erratic price of fossil fuels, and which has caused, of course, enormous amount of instability around the world. And then we also have the dropping of the price of the battery. The battery, which is used when the sun doesn't shine and the winds don't blow, the cost of battery power is going down dramatically. And some people think that a combination of all these different factors, plus a change in the governmental structure and attitudes towards solar, is going to give us a solar revolution. So with us once again today is Travis Bradford, author of the book Solar Revolution. And now I would like to introduce our very special guest for today. You know, everybody complains about the weather, but no one does anything about it, said Mark Twain. Well, here's somebody who wants to do something about it and solve the energy crisis to boot. He's Travis Bradford, author of the new book, Solar Revolution, The Economic Transformation of the Global Energy Industry. He's a Harvard MBA with business experience. He's the founder of the Prometheus Institute for Sustainable Development, and he believes that the solar revolution is inevitable. Given the soaring price of fossil fuels, given the fact that one day we will run out of them, and given the decreasing costs of solar power, it's inevitable, he claims, that we're going to see a solar revolution. But will this revolution be bloody? Will this revolution require enormous disruptions in our lifestyle? Perhaps even raising the prospect of a collapse of the atmosphere unless we can reverse these trends in time. That's not clear at all. However, Solar Revolution makes the claim that we are within striking distance. We are within striking distance of making solar competitive with fossil fuel technology. And here is an economist and businessman who has the facts and figures to back it up. Once again, our guest today is Travis Bradford, author of the new book, Solar Revolution, The Economic Transformation of the Global Energy Industry. The first question for you is, how did you personally get interested in solar energy?
My personal interest in solar really comes from my background as a mergers and acquisitions and buyout professional in New York, and further as an investor as private equity and a hedge fund. And I really began to think about the way that the energy infrastructure was unfolding and where that was going to create economic opportunities. I really didn't come at the solar energy industry from the environmental side, but really more from the business and economic side. And in my research, came up with some interesting conclusions about its potential that I don't think are widely appreciated yet.
Okay, well, let's talk about the present situation with regards to fossil fuels. First, oil. Give us your prognosis about how oil consumption will grow or decrease over the next 10, 20 years.
Well, the consumption in oil has been pretty steadily growing over a long period of time. And the available supplies have also been growing, but a lot of people talk about the inevitable peak in production of oil. The U.S. oil production has leveled off in the early 70s and has been dropping ever since, even despite our best efforts at bringing more oil out of our available reservoirs. So with consumption continuing to rise and not a lot of plans in place to use it more efficiently, CAFE standards, the fuel economy standards have not been increasing in the United States. We're really getting to a point where consumption and the available supplies are getting stretched, and prices have risen, and they will probably rise further, though. A lot of my ideas about where the energy industry is going don't necessarily presume that energy prices will rise above today's level.
Well, we've had some guests on exploration, including the provost of Caltech, who mentioned that there is something called Hubbard's Peak, which is this bell-shaped curve of energy supplies, and we're at the top of it, and we can only go downhill, in which case there could be massive disruption in the world economy. But what are your thoughts?
Well, the science is increasingly well understood. Hubbard's Peak has been understood since Hubbard initially was proved right in the United States and North America in the early 70s. A number of countries have passed their Hubbard's Peak, and now the remaining supplies are increasingly concentrated in regions of the world that are thought of as less stable or secure. The problem is, on top of the Hubbard's Peak issue, though, is that the entire supply infrastructure is stretched thin. There's not a lot of spare pumping capacity, even in the Middle East, where historically they were able to act as a pressure valve for world demand. And the process of getting the oil from where it's pumped through shipping, refining, and delivery to where it's needed has been stretched very thin in the last 25 years, and that's causing serious systemic problems that are as much a risk as running out of the fuel supplies themselves.
Some people have stated that we would have to find a new Middle East every 10 years in order to maintain our current consumption, and especially with China and India beginning to enter the world oil market in a big way. Well, that's not going to happen, right? We're not going to find another Middle East every 10 years. But what are your thoughts?
Well, that's, I believe, your statement to be true. And what it will mean is that inevitably we're either going to have to use oil supplies more efficiently and effectively, or prices are going to rise. And in my estimation, both of those will have to occur. But it makes it for a very powerful economic opportunity for the rising portfolio of alternatives.
And what about coal? The United States apparently has enough coal to last for 500 years, according to some estimates. But what about the environmental costs and the costs of liquefying coal? What about the dangers and promise of coal?
Yes, the number that you stated, I think, is at the high end of the range of estimates. Certainly when you imagine that we're going to continue to increase our consumption of coal, the rate of depletion increases, and I've seen estimates that are in the decades range, not the centuries range, of the availability of coal to meet growing energy demand. The liquefaction process, turning coal into liquid fuels for transportation, is an well understood process, but the environmental impacts, as you alluded to, are devastating unless we can figure out a way to capture and sequester the carbon. And there's lots of talk about that, but there's not a lot of good business models, and there isn't really the global focus that would need to exist in order to feel confident that that's actually going to be done. What my concern is that we'll continue to use coal out of economic necessity, and we will forget that there are these environmental impacts unless there's a major sea change in sort of global political will.
Okay, now let's get to the heart of your book, Solar Revolution, the economic transformation of the global energy industry. And let's talk about the economics. If you talk to the average homeowner, they would say that, well, yeah, solar is great, but only Hollywood millionaires who can afford it have these beautiful solar homes. And who can afford that? So what do you say to people who say that solar is a luxury of the Hollywood elite?
Well, that certainly people with the available capital and time and resources have the luxury of being able to adopt systems for their homes. But that's I think, a function in many cases of the ones that have been publicized, not indicative of the way the industry is actually unfolding. The solar has taken off outside of the United States more than it has in the United States. Japan, Germany, have been world leaders due to good public policy programs and local consumer demand for solar technologies, and those certainly aren't on showcase homes. They're mainstream homes and farms and businesses. In the United States, the market has actually developed on the commercial side, meaning on businesses or warehouse facilities, larger commercial systems. Wineries have been early adopters of solar energy, and so the commercial market really is taking off a lot more than the residential market has. But just in the last year, the federal government instituted its first solar energy tax credit for systems in 25 years, and California instituted what's known as their Million Solar Roofs Initiative, funding $3.35 billion for new, small, medium-sized systems in the state of California, making it a world leader in deploying solar technology. So I'm not sure that the technology is going in just pet projects, but it really is a mainstream technology at this point.
Okay, let's talk about cost per kilowatt hour. In your book, you have a chart going over the different efficiencies that we have with regards to different energies and cost. For coal, you have it at roughly 5 cents per kilowatt hour. For geothermal, for hydropower, even nuclear, we're talking about 5 to maybe 10 cents per kilowatt hour. But solar, you have it here between 15 and 25 cents per kilowatt hour. So explain to us now the economics for the homeowner.
Well, that's for starters, homeowners can't generate coal-based power at those rates. The rates that you're looking at are utility scale power. And there's still the cost, once a utility has generated that power, there's still a cost to get the electricity from where it's generated to where it's needed. And in fact, that's a very large part of what consumers see in their end utility bills. It can be as much as half or more of the total cost of electricity. So what's happening in the solar industry is that it's bifurcating so that there is utility scale solar power that's being developed. 2.5 gigawatts of new capacity have been provincially announced in the last year for centralized concentrating solar plants that can actually deliver electricity, somewhere between 9 and 15 cents a kilowatt hour. And the economics there are that it doesn't compete with coal or nuclear, which provide nice, steady baseload power, but it actually provides the daytime peak and intermediate load power, which is the most expensive power for utilities to generate. So when you compare solar at the utility level to the solar to the energy and electricity that it replaces, it is much more cost effective than people think. But from the other part of the bifurcation is that at the home, it's not the correct comparison to look at the cost of solar at 15 to 25 cents a kilowatt hour on the home versus what it costs the utilities to generate electricity. What you should be comparing it against is the cost of the electricity that the consumers are buying, the cost per kilowatt hour on their electricity bill, which in many places, including California, gets you to cost effectiveness much more quickly. The other thing I haven't mentioned yet is that there are these solar incentives that bring that cost down. The costs that you mentioned are unsubsidized costs. But in the state of California, the government pays 40 to 50% of the cost of installing a system, and all of a sudden you can begin to see that the economics are pretty compelling for a home or business owner.
Okay, and at what point in the future will solar actually become right neck and neck with fossil fuels?
Well, I maintain that it already is, and what I mean by that is that the cost of generating solar on the home or business is already cost effective for a number of people who do the math correctly, who look at the appropriate methods of financing these systems. That there are many more applications where solar is cost effective than are currently being serviced. And the problem today isn't demand. The problem is supply. The industry is rapidly trying to deploy the capital to make these solar panels available, but demand continues to outpace their ability to meet it.
So, Mr. Bradford, the question is, what can we expect for the future of the economics of solar energy?
So, but what we'll begin to see now that we're in a situation where it's cost effective for a lot of users, and the volume of solar increases, it brings down the costs over because of scale and economies of scale and volumes and just getting better at it, which is what we've seen a lot in these electronics industries. And the costs continue to come down, and every time the cost comes down, more and more people find it cost effective. And this has created a positive feedback loop, the end of which will be a few decades from now. But the world and the energy infrastructure that we rely on will be radically transformed by that.
Okay, well, let's paint a picture as to what the future may look like. What will the home look like of the future? Are we talking about taking the state of Arizona and blanketing it with solar cells and then shooting the electricity out from Arizona? Are we talking about decentralized solar where people put solar panels on the rooftops? What is it going to look like?
Well, there will be, like a good economist, I'll have to say both. The energy will be generated in a lot of different ways in different places based on the resources and the resourcefulness of people in these locations. So utilities will decide that solar provides good daytime power, and they will create these larger centralized systems, and most likely in the sunniest places. There are large systems that are going up now in Arizona, Nevada, California, and that will continue to spread to other, less sunny places as the economics continue to improve. Also, homes and businesses will begin to adopt it because now, for the first time, they have an alternative to the grid-based electricity monopoly that they've been purchasing their electricity from for many years. And what you'll end up with is a hybrid system. And this is very similar to what we have seen in recent technological transformations in telecommunications and computing, where we used to have these large centralized systems, and then because of the economics of semiconductors and being able to put power at the point of use, the systems migrated from large centralized systems to hybrid distributed systems where there was a lot more processing power at the point of use. And just because we all have PCs on our desk, it doesn't mean all the mainframes go away, but what you create is a much more robust infrastructure that's going to look very different than what people are used to today.
Okay. Now, what would it take to jumpstart this technology, given the fact that solar right now only yields a small fraction of the total energy that this country consumes? What would it take to jumpstart this technology? Mass production, tax credits, another oil jolt? What will it take to get the technology really up into the mainstream?
Well, I certainly think that all of the things that you mentioned would be good starts. We've already experienced this year, as I mentioned, federal tax credits, the first in 25 years, to help make this more economic. We have seen a lot of interest because of the California incentive program. $3.35 billion is a lot of money going into building the industry in California, which will be available for other states. That expertise will be available in other states as they decide to promote solar further. And a lot of money has flown into the capital markets this year to expand the production of solar cells, and some federal money has also gone into additional research and development. So there's a lot of things that are moving in the right direction. The things that we need to do now are the two main things that I think are important. The first is we need to get national interconnection and net metering standards. What that means is that we need, right now at every state, and even in some cases local governments, can dictate how and when a consumer can decide to put solar on their home or business. And we need to, and that makes it very hard for installers to create a standardized product because they have to meet different requirements in each of these jurisdictions. What we need to give people the right to install solar when they want to, and under some standard sets of technical parameters. That will certainly help the growth of solar. The second thing that we need to do is we need to recognize that every time we build a building that is not using the most efficient methods of energy use and insulation and energy efficiency standards, and we're building buildings that don't take into consideration the ability to generate electricity, we are wasting effort. We need to make sure that builders are thinking about on-site generation of solar energy in conjunction with all the energy efficiency technologies that are available when they're designing and building these buildings. And the California solar program alludes to this because it requires by 2012 that builders in California offer solar as an option on all new homes. And we need more of this. We need people to know that they can put this in at the time that they construct their building, which dramatically reduces the cost of installing it, allows you to finance it as part of the financing that you're already getting to pay for the building, and then not have to go back and retrofit it later in a way that might be suboptimal. So we need to start thinking a little bit better about how we're building buildings so that we stop making the problem of inefficient energy use worse.
And what about competition from other kinds of technologies, such as nuclear? How would you compare solar to nuclear?
The portfolio, there are lots of good options for energy, and different places are going to use different solutions to meeting their energy challenge. The countries like Iceland that have lots of geothermal resources are going to use geothermal resources. They have more reliable geothermal than they have reliable sun, and that makes sense. Brazil is doing a lot with biofuels. They have a lot of farmland. They can produce biofuels relatively cheaply, and so they have become a world leader in that. They even within the United States, different regions have different resources. Some have more wind, and so that's going to be more economic for them. Some have lots of sun. The United States actually has, among industrialized nations, has a tremendous amount of sun per capita. So solar should be a big portion of the solution here in the United States. But the one thing to remember is the economic arguments that solar, by providing a distributed solution, is very different than large-scale nuclear, large-scale wind, large-scale geothermal. Which, to be economic, all have to be generated in very big plants and then distributed through the transmission and distribution infrastructure. And solar is really the only technology, the only widely available technology that can sort of circumvent that transmission and distribution infrastructure and provide its power directly at the point of use. So it doesn't directly compete, at least on the distributed basis. It actually creates a new economic choice, a new competition, a new product for consumers to adopt. So regardless of what happens in the portfolio of energy choices that the utilities make, solar's opportunity is sort of outside of that portfolio mix, which is why it's not directly comparable.
And let's also talk about hydrogen. Hydrogen power is really not a way of generating electricity. It's nothing but a way of transmitting or transporting energy from one point to another. Some people say it's complementary to solar. A solar hydrogen economy is one alternative. But what are your thoughts about hydrogen and solar?
Well, I think your points are very good. Hydrogen does need an energy source to create it. And the problem, again, is hydrogen can be generated more economically today in centralized locations, but then you still have to get it to where the power is needed. We can't forget the cost of transporting power, and transporting hydrogen is a complex and expensive process. The way but the problem with like a distributed solar architecture is that it needs some sort of on-site storage so that you have access to energy even when the sun's not shining. And the two ways that you can do that are through batteries or through making hydrogen out of the solar, and either through electrolysis or direct hydrogen generation. And there's a lot of promising technologies in that. So at the end of the day, it'll sort of depend on whether the economics of batteries or the economics of hydrogen improve faster, and the economics will depend not only on cost but the life of the systems and the reliability and a lot of other factors that go into making economic decisions. But at the end of the day, there's to tie this back to your initial questions about oil. The only way that we're ever really going to solve the transportation fuel problem. We can partially solve the transportation fuel problems of oil through liquefaction, if we can do so in an environmentally responsible way. We can partially solve them through biofuels, but there are serious limits to those models, particularly when you start moving into places around the world that don't have access to the capital and the farmland and the water and all the things that you need to go into those systems. The real way that we're going to solve the transportation fuel problem is to reattach the transportation infrastructure to the electric infrastructure. And today's hybrid vehicles and the emerging plug-in hybrid vehicles are the way to do that. You basically can use electricity to help power or ultimately power your transportation infrastructure. But these plug-in hybrids are going to have a lot of storage in them. They've got to have batteries, or they've got to have hydrogen fuel cells to store the hydrogen energy. And by reattaching these solar sources of clean electricity to the energy storage available in hybrids and plug-in hybrids, you have a complete solution that I think is what will inevitably emerge as the paradigm for our energy future.
Well, unfortunately, we have run out of time.